just gonna do the museum. And so that is the coolest museum ever.
Wow.
Every I was walking around, that one. I mean, everybody.
Yeah.
Indiana Jones, like stuff
That's
you would
so
never
cool.
expect to see. It's
Hey,
crazy.
Mr. Lacey, I'm going to send you the link really quick.
Okay.
Send it to all of us.
Yeah. And is it up and rolling?
Yeah, it's up and rolling.
Okay. Good.
Hi, YouTube.
Good job. Good job, Archer. Good job, Archer.
Yes.
All right, here we go.
And then also sports period engineering class, right?
Liam, where are you getting the stuff on? Right there?
Third?
Yeah, give it up to the thing. Oh, send it to us. I think four, because you have like, I think like
Yeah, Meadows M does not have an engineering class.
Yeah, I didn't show up the other ones.
it should show up like.
All right.
Yeah, what's up?
This is going to be cool.
Did you see my email that said that?
You get your questions ready?
I do got my questions.
Yeah, there's only one I think I can't answer accurately.
All right.
But I'll.
You said-
They're watching you.
You said
Oh,
question
cool.
7, right?
I think so.
Okay, how'd you get it? Got it. Okay, I got it now. Thanks. All right.
All right. Hey, everyone who's just tuning in, we are just about to get started. We're kind of just getting set up still.
Just working out some kinks right now, but
You'll both microphones.
Yep, we're set.
It says
And
restricted
that's the
modes.
end of, now it's my lunch.
No, start this class.
Okay, you should.
Yeah, I can't even do it. No, it's because restricted mode is turned on. Try it like on your phone. No, this will. I think it's like HDMI sound. It works. Yeah, still video no lock.
Is it working?
No.
can you get it on one of those?
Yeah. Go.
What if you just watch?
The teacher's computer.
Yeah, why don't you
Run it
just-
off the teacher's computer? Because we're just gonna run it off. These are screws. So go to the shop right now. We don't need this. You're gonna pull it up on his computer.
Somebody needs to text.
I'll text Seth.
and Brooke. And, wait, go to Miss Keith's class. And go tell Seth that he needs to pull it up on her computer. And then go from there. Hold on, listen. Go from there to Mr. Dalzell's class and tell Brooks. Right?
Hey, Angela.
He's right next to you. Tell him the same thing.
Can you hear anything? I can bring it up front.
Just talk like right into it.
Hello. Can you hear any?
Yes.
I'm just taking apart a controller while we wait just for the fun of it. And if anyone wants to come in and look at it and ask questions. I'm just taking apart a controller while we wait just for the fun of it. And if anyone wants to come in and look at it and ask questions. I'm just taking apart a controller while we wait just for the fun of it. And if anyone wants. Great echo. Great echo.
Angela, I'm gonna text you the link. And that way you can switch to the chat.
Okay. Oh,
Well, I think so.
I viewed on here.
Is somebody else asking? Or you're just.
I'm gonna read off the chat. You don't have to. So
We can just repeat his question though.
Yeah.
Okay.
All right. Are we good? Archer?
Yeah.
All set?
I think they're still running around getting classrooms set up though. So should we
Oh, yeah.
wait to.
We'll wait like a couple minutes.
No, I think
So
go ahead
you know
and
what
just
we're
get started, because I know he's already
We're
on.
learning it.
And I'm sure.
Yeah, I know.
he's already
Not
on.
the laptop.
So you're probably.
It's the laptop.
Okay. Well, hi everyone. I am Nasi Feles. I'm a mechanical engineer with Andrews Cooper, and I'm happy to be here chatting with you guys. I know Angela's got some questions prepared for me, but you guys will also have the chat open in the live stream. You guys can send in questions, and we'll have somebody read them off to me. So, just a little bit of background. grew up in the area, grew up in Redlands, went to college in Riverside, and worked at Sorensen Engineering for about 6 years here in Yucaipa, and then went on to work with a company called Andrews Cooper, where now I do integrated engineering team stuff. So we're a team of engineers who we take contracts to different companies. And so my last contract was to an automated pizza machine for stadiums, which was a whole lot of fun. And now currently I'm on a contract with Xbox, designing next gen console accessories. Let's put it that way. And I can answer questions about lots of the old stuff. My engineering mentor actually was the mechanical engineering lead for a lot of the previous Xbox controllers. And now I'm working with next gen stuff, so I can answer a lot of questions about some of the older stuff. And just also I want to talk to you guys about like my journey through school, my time as an engineer, some of the challenges we've had to overcome as an engineering team. And yeah, so Angela, go ahead and just start
Cool.
firing questions away. I'm open to them all.
All right, so like, just like going off of what you just said right there, like, just go back to the beginning. So, what inspired you to pursue a career in mechanical engineering?
Not as straightforward as you guys with an engineering program. In high school, I was getting bored during my senior year. I had no idea what I wanted to do. My family's all small business owners. I kind of thought I would work with my dad in the auto repair shop or with my grandparents in the restaurant industry. But I wanted to go to school and college for something challenging. So I was actually giving a customer a ride one day. And I was like, what should I do when I graduate? I want something challenging. He goes, oh, just come be an engineer. Be a civil engineer. Work for me in the city. He was the civil engineering manager for the city of San Bernardino. And so I started my freshman year in civil engineering. Found out very quickly I hated it. So I switched to mechanical because I always loved tinkering. I had taken apart an Xbox controller before I even ever went to college. I had taken apart many things in our house. And so like it fit naturally with me to move into mechanical engineering. I didn't know it was a category even when before I went into college. So for me, that's kind of how I got it started, and I absolutely love what I do now.
That's awesome. So then from there, what made you go into working on like gaming hardware and like these Xbox controllers?
Right place, right time. It is really hard to get a job in the gaming industry, but because of my college roommate's experience with Hewlett-Packard and his proximity to it when he lived in Washington, he got a job with Andrews Cooper and then got me a job with Andrews Cooper, where they happened to be experts in product development for consumer electronics. An example of that would be an Xbox controller, VR headsets. My manager actually was one of the lead engineers on the Valve Index. So I've been in close proximity to a lot of the gaming industry now, and I will probably spend the rest of my career working with the gaming industry.
That's awesome. Cool. So from where you are at right now, like your role in your team, like making all this stuff, where do you see like moving forward then? Like, where do you see yourself moving forward?
So I did just get promoted to senior mechanical engineer at work, and so that's kind of my like literally just 2 weeks ago.
No way.
So my moving forward is I'll probably spend the next 5 years in the senior space where I'm starting to train up new associate and staff level mechanical engineers, and looking to become an engineering manager one day, or I guess more of a project lead, where it's like I'm more setting the architecture of what we're doing instead of doing some of the detailed design. Because a lot of my day-to-day right now is taking apart and doing the full design start to finish on it. So
that's crazy how you went from like completely undecided, just asking your friend, you know, like what should I do, to like being like a senior high-end mechanical engineer. That's awesome.
Yeah.
So question number 2, like what would you describe a typical day as your role as a mechanical engineer?
So that has varied based on projects and work. When I was at Sorensen Engineering, let's say my first year, I was on a lot of project-specific things, looking at manufacturing of a specific part. I then transitioned to overseeing a whole department, and then I transitioned to being a quality engineer over the plant. And those were all very different roles. But currently on this project with Xbox, I'll kind of talk on more on a weekly basis. I spend about 10 hours a week in meetings where we talk about what's going on with the whole integrated team, understanding all the challenges that people are having. So we have opportunities to brainstorm together, collaborate, and then also just get the adjacent teams within the Microsoft. Because there's a software team, there's an electrical engineering team, there's a safety team. And so we all like work together to communicate throughout the week
Mhm.
about what's going on in each of our areas. And then day to day, I'm currently working through some hot topic issues with controllers. I'm going to leave it at that.
All right.
So I'm spending a lot of time trying to solve problems around some challenging engineering things that my mentor 10 years ago was trying to solve on a previous Xbox controller. And I know that Sony is also trying to solve some of these problems. And there is a lot of time that goes into coming up with an answer. So some of it's market research, some of it is doing 3D design. I probably spend 80% of my time doing 3D CAD using Creo Parametric. I know you guys use Fusion here, Autodesk Fusion. Similar to that, parametric modeling to make the 3D model. I have a 3D printer at home so that I can prototype parts. So I print prototypes probably once a week to get each iteration to see where it needs to improve, making sure assembly works properly, and that stuff just generally fits the way I'd want it to.
Nice. How long how long have you been working on this controller so far? Like this new?
So I spent a year and a half working on the previous controller, and now as of end of November, I started work on a newer controller.
Just new after new after new.
Yeah,
huh?
yeah. So you
that's
have to be
cool.
ahead of development. Development takes a long time. I'd say for most products, not just talking Xbox, most products you're going to have a 18-month to 3-year product development cycle, depending on the complexity of the project.
Wow.
So things don't run super fast. Now, if you're a smaller company and you're trying to make it into a market space, you may run really, really fast to try to just make it to market to get a little bit of the market share and then take time on your next one. So with the automated pizza machine, if you guys start to Google food automation, that's another hot topic that I've worked in. Getting into the food automation space, we worked as fast as we possibly could to get a product from nothing to market in 6 months.
Wow.
We got about 5 units. We spent the next 2 years, and I was only on for the tail end of this project. The last year and a half of this project I was on, so they'd already gotten it to market. The next 2 years was developing the version 2 of the system that had all the features, a lot more of the bugs worked out. So yeah.
Could you actually explain that automated pizza thing while we're on the topic, sort of?
Yeah, so you take a pizza dough, whether it's stretched out, frozen, or however you do it. The goal of this machine was to be able to spit out a pizza every 30 seconds. That was kind of the design space. If you go into a restaurant, there are standard 6-foot, 8-foot workstations. We wanted to get rid of a standard 6-foot stainless steel workstation and be able to put in there, you'd be able to put your sauce, cheese, pepperoni, and up to 6 granular toppings. So that'd be like your sausage and your pineapple and bell pepper, and be able to, in an engineering way, to say, yeah, I want exactly this layout.
That's cool.
And so we spent a lot of time in terms of how we dispense ingredients, how we would fresh cut our pepperoni, because that was one of the restaurant requirements, is that they wanted fresh cut pepperoni instead of just like dispersing slices. We were cutting it right onto the pizza.
Awesome. That's so cool.
Yeah, and so it's a pretty large machine. It was a 3-module unit because it had to be able to be broken down into modules to fit through a standard door.
Oh wow.
There were some restaurants that we went to integrate into, and we didn't fit through their door. And so there was one restaurant that they decided to take out a window to put a machine through the window, and then put the window back
whatever
up.
works, right?
Yeah, whatever works.
That's cool. So we actually have a question from Mr. Bag's class.
Yeah.
He's asking, how did you decide your college and what made you decide your major?
So for college, again, I didn't have much of a plan in high school, and I wish I had more of it, but I went to a smaller school. I went to ACA in Redlands, and we didn't have an engineering program. We didn't have a lot. It was just more standard high school stuff. Didn't exactly know where I wanted to go. I applied to Cal Poly Pomona, Cal State Fullerton, Cal Poly San Luis Obispo, and CBU, all for their civil engineering program. Because again, I had talked to a customer of my dad's that I was giving a ride from the auto repair shop back to his work when he dropped off his car with us. And he said, do civil engineering. It'll be challenging. You'll enjoy it. And turns out I wouldn't. Freshman year, I changed to mechanical engineering because at CBU, where I ended up going to college, that was a couple of factors. Long story short, my name is Nasi. My legal name is Thanasi. So when I submitted my application, I went under Thanasi. My letters of recommendation and my transcripts from my school that were sent under Nasi, which meant they didn't connect when they got to the colleges. So Cal State Fullerton, Cal Poly Pomona, Cal Poly San Luis Obispo all treated my application as incomplete. I didn't realize that. And so I didn't get accepted to any of them. I didn't even get rejections. I just got incompletes. Started calling. They weren't able to help me. They were like, hey, we're past our deadline. Yep, you missed the deadline. I'm like, no, I submitted everything. And CBU was actually the only college willing to help me and get me accepted. So that's how I ended up at CBU, just by chance of a mistaken name situation. So be careful with
Jeez.
your names. Make sure your school name and your legal name that you're applying under match up, because that was my issue with where I went to school. Now, I loved my time at CBU. Their engineering program is so hands-on. It's incredible. I had some friends who went on to do engineering at Cal Poly Pomona and UC Riverside. And the freshman, sophomore year at CBU are incredibly hands-on compared to those other programs, or at least it was when I went through it a long time ago.
Yeah.
Like 10 years ago.
10 years.
But I really enjoyed it. And so picking my major, CBU had a thing called engineering seminar, where once a week we would get to hear from an industry professional about what their day-to-day looked like. And like week number 5 was a civil engineer. And I heard his job and I said, there's no way I'm going to do that the rest of my life.
Oh, okay.
And so, again,
That
I
was
had
the
no
turning
exposure.
point.
And that was the turning point. So I went from there straight to the academic office and I said to the registrar, or I don't know, academic counselors, I said, hey, can I change my major to mechanical? Because I heard this other mechanical guy speak 2 weeks ago and his job was awesome. He was a mechanical engineer who worked for, I think it was Coors Light or Bud Light. And
A mechanical
engineer who worked for the automation stuff for bottling of these beers and stuff. It's like, that's so cool. And he talked about the mechanics of it and like what they do. And I was like, this is so awesome. I want to do stuff like that. I want to work with my hands. And all the civil engineer guy was like, yeah, I design bridges and parking lots. And now granted, it's still a great field. I know a lot of friends who really love civil engineering, but for me, loving to be a tinkerer, loving to make stuff, mechanical engineer was the way to go. And so learning that I loved hands-on activities, was very helpful. It would have saved me some time and some money had I known that going into college, which is why you guys' program is awesome. You guys just did a trip to an injection molding site, and you guys are doing other field trips. I know you guys seniors do field trips to Sorensen Engineering as well, and I've led some of those tours in the past through my department, and like that stuff is so helpful to be like, that's cool. I could see myself doing that because there's a lot of cool stuff in engineering. So yeah.
Did your high school have any like anything to introduce you into like that kind of stuff, or
Not at all.
So out of high school, you had no clue.
I had
like,
no idea what I wanted to do.
Wow.
I'd grown up working either in a restaurant or in a auto repair shop because my family were small business owners and we're immigrants from Greece, and so they were small business owners, and so that's what I grew up in, and yeah.
Awesome. So next question on here is, what is the hardest part of making the controllers?
Everyone's requests. I mean, like so much of working on a like high visibility product where Xbox is going to sell, I don't know, 100 million controllers in the next 10 years, and they've sold 100 million in the last 10 years. Like there are a lot of people who make requests about what they would want in an Xbox controller. And so we take a lot of that into account. And so we spend a lot of time going like, hey, we have user feedback and user studies and petitions that people have made up. Hey, we want these things into your controller. Okay, well, we want to meet those things. And sometimes they're like, it's a hard balance of like what features go into a controller and what doesn't. So space constraints. Someone earlier was asking me a question about the D-pad on a controller, and we took apart a controller to kind of talk about it. And they were asking, if you diagonal press your D-pad, is it 4 or 8 like switches underneath there? Is it reading 2 switches at once, or is it reading like an individual switch for the diagonal press? And it's reading 4. One of the reasons behind that is just space constraints. Even if you look at let's see, it's the Razer Wolverine V2 Chroma, that controller has the micromechanical switches that are underneath the D-pad, and so does the new Turtle Beach Stealth Ultra controller. Again, they also just went with, if you want to press diagonal, you're going to press 2 switches at once underneath. It's going to look like a diagonal press to your user input, but it's actually just combining the 2 signals. And it's space, because these controllers are very small. And components are getting smaller with time. Micromechanical switches weren't a thing 10 years ago, but they became developed out of the mouse industry, like regular gaming mice, let's say, and a computer mice. And so space is a major constraint in terms of adding all the features that people want, because any extra feature takes up extra space.
That makes sense.
And if you want more battery life, okay, a bigger battery. Okay, well, where's that bigger battery going to go to? I just took apart this controller, and there is not much empty space inside this controller. We even had to cut out a part of the board to make space for the battery in the Elite controller.
Wow.
So space is a constraint.
That's crazy. How durable are they? Like the controllers themselves?
Very durable. We go through a lot of testing. Microsoft has, I'm like looking at Mr. Lacey's classroom here. They probably have 3 to 4 labs full of controllers that are getting tested the size of this classroom at any given time. It is like the loudest room at the Microsoft campus because it is just pneumatic cylinders, cycling buttons with force probes
Jeez.
hooked up to everything you can imagine, and sound. There's little audio mics next to certain buttons, and we're measuring things. There's sound isolated ones. We go through rigorous chemical testing. We do drop testing under a 250,000 frame per second high speed camera, and we review how the plastic flexes. Oh man, it is so much testing that goes into the durability. And there's a throw test, and like there is literally a mechanical robot arm that will take a controller and chuck it, because you know what? People do that.
Yeah.
People get mad at their game and they throw their controller at the ground or throw it at a wall.
Yeah.
And so we test for that. And so much of what we do is making sure that we have one of the most durable controllers in the market. There's a lot to say about, I'm going to talk stick drift. People complain about that, durability and stuff. But you start to run the numbers in terms of testing in a lab setting. And the Xbox controllers are incredible in terms of performance. They really are, because we spend so much time and money to know when they fail, at how many cycles they fail. This Elite controller that I took in, there's another sticker on the back here for this. It says not for sale here.
Yeah.
On this, actually, this one here says prototype 2 right in there. So this is a prototype controller from the old Series S and X, and then this one here is also a not for sale controller that we did. It was the 135th controller that we put through thumbstick rotation testing, and it went through a lot of cycles.
Wow.
So we do a lot of durability testing.
How many like controllers like go through your
Hundreds, thousands,
Jeez.
lots.
That's crazy.
It is so many controllers that go through.
That's insane. Is that the bell for? No, keep going. Okay. All right. Another question. How tight are the tolerances you have to work with when designing the controller?
I would say pretty tight. From my experience, coming from Sorensen Engineering, which right down the road, they do micro machining. Their tolerances are so tight at Sorensen that I came to the controller. I'm like, oh, these are loose. This is nothing. No big deal. But then I was learning that I'm working with plastic, and working with plastic means you need looser tolerances. So once you get in engineering, you'll maybe start to talk about this in college, but there's like commercial tolerances and there's commercial fine tolerances. A lot of areas of the controller require commercial fine tolerances. I could throw out numbers, but they don't really mean anything to you guys without anybody having the experience.
Yeah.
But we do, when it comes to the overall feel of the controller and the performance aspects, we hold commercial tight tolerances. If it comes to something that's like just a rib on the inside, it's a normal tolerance. But when it comes to what you're holding in your hand, we will pay extra money to make sure it's meeting a higher tolerance spec.
Cool. Sounds like Xbox is like the top dog, you know?
I can tell you, so one of my parts of my job with Xbox is to be the most knowledgeable person on our team about competitor controllers. So I have a small collection of competitor controllers at home. And there are some good competitors and there are some bad competitors. Some of the controllers, I'm not going to throw them in on the bus. Some of the controllers have taken apart going, wow, they rushed this engineering job. This is no good. And then you open up some and you're like, wow, they spent many, many hours designing this intentionally. And I think that's the thing about Xbox is they will spend literally tens of millions of dollars to develop a controller to make sure that it functions the way they want it to and the way the users want it to.
Wow. That's crazy. What are the Hall effect joysticks and why are they a major selling point in modern controllers?
how do I answer this? Okay. So the way a joystick works is you're measuring the X and Y position of two levers essentially to tell where the joystick is. Hall effects uses magnets to do that versus a regular joystick uses a linear encoder type thing or rotary encoder. And so people really like Hall effects because there's less of a mechanism to record, but also engineers, I don't like Hall effects because it's influenced by magnets. And there's magnets inside this controller. There's magnets in the Hall effect triggers. And there's magnets to hold stuff together. And there's magnets in motors that drive vibration. And so, like, there's a lot of magnetic shielding that has to happen with Hall effects.
Mhm.
And some of the Hall effect stuff is not up to par with mass manufacturing. Hall effects is still a new hot topic item. And currently, no one is really manufacturing them in the tens of millions a year.
Jeez. All right.
Yeah.
Wow, that's crazy. So what are the main differences between your controllers and PlayStation controllers?
PlayStation has a different layout, and I like the PlayStation layout better.
Oh.
It just feels better in my hand. I like having the left thumbstick down where the D-pad is. But you know what? I work with Xbox, and Xbox also has a good controller. And there's a reason there's a good split, and there's a reason you can buy aftermarket Xbox controllers with the PlayStation layout, and you can buy aftermarket PlayStation controllers with the Xbox layout. It's a total preference thing. The new Sony DualSense Edge, the new Elite controller that Sony came out with last year, last year, is a great controller. If I was picking for myself playing daily between the Elite 2 and that controller, I would probably pick that controller. That's just personal preference, though, because I have people on my team who would say they hate the layout. They hate having the thumbstick down here. So I currently play. I'm a big gamer. I play like 10 hours a week, you guys, at least. I might play more than most of you guys. It's what I get off of work and I play some video games. I play video games in the evening. I play video games on the weekends with my friends. And so I'm currently playing with the Scuf Envision Pro. If someone Googles that, you guys can see it. The Scuf Envision Pro is a PlayStation layout controller. But I do still play with my Elite controller. I like the paddle layout on the Elites better than anything. So the Elite controller has the 4 paddles in the back of it. This one's taken apart. Ergonomics are definitely the best on the Xbox controller. So it's a lot of preference, but Xbox makes a really good controller.
Awesome. And I lost my train of thought, sorry. Okay. Another question is the stick drift on the Xbox controller the company's or the player's fault?
Both. If you drop your controller and you start getting stick drift, it's your fault.
That's fair.
Like I said, we do a lot of testing. We do a lot of drop testing. We do drop testing and then thumbstick rotation testing. And we do almost any permutation of testing you can imagine we try to do on these controllers. But it is an engineering challenge. And so the thumbstick module is not made specifically by Xbox or by Sony. They're purchased. So I know Alps is one of the leading, if you guys Google Alps Electronics, Alps thumbstick modules, they're one of the leading manufacturers of thumbstick modules for the industry. So they're in a lot of the PowerA Fusion was using them. Now they switched to somebody else, and Turtle Beach was using them. And I know there's just a lot of people who've used Alps stuff. So is it all Microsoft's fault? Hard to say. Is it all the user's fault? Hard to say. But it is a definite problem that every controller company is working on improving.
Got it. How much 3D printing do you do?
A lot. My 3D printer runs. Waiting for the bell. I have an SLA 3D printer at home. If someone Googles Elegoo Mars 3, that's my consumer printer that I use at home. I do print functional prototypes with it for work, and I print stuff for personal use. I've also had I've had a couple different printers in the past, but it doesn't matter. I really like doing SLA printing. We do a lot of 3D printing in the engineering space. At Sorensen Engineering, they've got an army of like 15 Form 3s that they do 3D printing for functional and for prototypes of stuff. I'd say most mechanical engineering offices now have at least one 3D printer. Our offices, we've got my company, Andrews Cooper, has an office in Portland area, Seattle area, and then a couple hours south of Portland. And each office has a room full of 3D printing for prototypes. It's just so nice to be able to spend, I don't know, $5 on filament for a large print and get something in your hands to evaluate.
Nice. All right. Next is, how useful is computer science / coding in your field?
For mechanical engineering, no, but I work for cross-functional teams that do the coding. So like there are, there's a whole team of software engineers who are working on this controller to make sure that they have software ready for all the features that we're looking on adding to the new controller. There is, I mean, your son-in-law has done some game design stuff, and so there's software and computer science stuff is so vital in terms of everything we interact with. So though this is a mechanical thing that I do the mechanics on, I don't know any programming at all. I'm totally a noob in that, but I know I work with a lot of people who are really knowledgeable and build really nice software.
All right, cool. So I think we're going to be wrapping up soon, right? Quick.
We have one more chat.
One more question, and then I've got one too. But
I will make them quick.
what is it?
What are your thoughts on Joy-Cons?
What is Joy-Con?
Nintendo
Oh, the Nintendo Switch Joy-Cons? I like my Nintendo Switch. I've never had a single issue. I've had it since the day it came out with no issues with my Joy-Cons.
Nice.
So I know people have problems with them. My brother has gone through like 7 or 8 sets of Joy-Cons.
That's
But
crazy.
I don't know. I've played through Breath of the Wild and Tears of the Kingdom multiple times each with my Joy-Cons without any issues, and lots of Super Smash Bros. But yeah.
Nice.
So when it comes to designing the controllers, I know that there's a lot of, like, you take inspiration from past projects and what Xbox has done in the past. When it comes to reverse engineering, how does that fit into a mechanical engineer's, like with something like a project like this? Like, how much reverse engineering do you do?
There's some, like, and it's sometimes not even like a straightforward reverse engineering. Sometimes it's looking online and looking at other products for mechanisms that might work with what you're looking to do. So like we might take apart a camera and be like, hey, how did they do this battery door on a camera that has this nice click to do a battery door on another product? The Microsoft lead that I've worked with has some past experience in cell phone design, and so he uses a lot of reverse engineering type ideas from that. But also there's times in the past in my previous work where I've had to reverse engineer a part of a machine that was running until it broke because it was designed in 1960 and nobody had any technical specs for it. So we had to measure it, redesign it from the ground up, reverse engineering what we had in our hand that broke, because sometimes you just don't have the old plans that somebody else before you had made.
Yeah, that's wild. Probably last question. Do you have any advice to give aspiring mechanical engineers?
Yes. Learning how to learn is the most important thing, I think, for schooling. I know we got teachers in here, so hopefully I don't make anybody mad, but I think learning how to learn is so important as an engineer, because as I've switched positions at Sorensen Engineering, as I've switched projects at Andrews Cooper, and even across Xbox products, I'm learning how to learn constantly. I will sometimes have a product that I'm working on designing a sheet metal piece. We've got a sheet metal spring here in front of me. There's times where I'm working on a plastic injection molded part. There's also a part I'm working on that's metal injection molding, which most people don't know that you can injection mold metal. And I've worked on large sheet metal frames for machines. I've worked on micro machining stuff at Sorensen Engineering. There's no way I could be an expert in all of these things, but I need to be able to learn quickly, because when my boss tells me, hey, we need you to switch over onto this thing, even if you don't know about that thing, you got to be very quick at getting up to speed with your team and be able to provide really good input in no matter what you're doing. And so learning how to learn is something that was told to me like while I was in school at CBU for my engineering degree. And it became so helpful when I got frustrated with classes. And I got frustrated with my English class going, I don't want to write a paper right now. Well, when I looked at it as like, okay, I'm learning how to learn how to write. Learning how to learn was so important for getting to the things that I was frustrated. When I was taking Calc 3 and I was really frustrated with some of the concepts that I wasn't grasping, I was learning how to learn to solve complex problems so that when I got into engineering, I could solve complex problems. So there's so much with learning, like, and just keeping your mind on that, like, learning aspect, because there's so much of school that is frustrating and you don't understand. I think I'm looking around the room getting some smirks. When I said English, I got some smirks. When I said math, I got some smirks. It is so important to learn how to learn, no matter what the challenge is, because your boss isn't going to give you an option to pick typically. You're just going to get thrown onto something and have to go learn and go do. So, like, I've learned how to do multiple CAD softwares. I'm proficient in Inventor, Autodesk Fusion, Creo Parametric, SolidWorks, because I've had to learn how to use those. I have a preference of which one I like the most, but I've had to learn how to use all of them on a daily basis. So learning how to learn is my advice to you guys. Be open to learning, even if the problem seems stupid in the moment.
That's awesome. That's great advice. So that's it. Yeah. Thank you, Mr. Feles, for
Yeah, you're welcome.
sharing all your knowledge, even though there were some things you maybe couldn't have said, but yeah, we thank you for being here.
Yeah, and also I'm here through the next lunch, hanging out. So if you guys want to come into Mr. Lacey's classes in L1 and come ask me questions, come take a look at the controller I've got taken apart here, I can definitely keep going through the next lunch hour.
Awesome. All right. That's a wrap.